So after you enter all information related to the model in the Excel, then it's a time to use the Excel solver package to find the optimal solution. So in order to remind you, our example is example 1. This example, this linear programming model, we have a maximization model, 2 decision variable and 2 different constraints. We enter all of these information in the Excel and we enter the formula function for the total, for the objective function and the constraint. Now we can use Excel solver to find the optimal solution. So first what you have to do, you have to go to the data ribbon and you have to use solver. If you don't have solver, you have to add the solver package to the data ribbon. You can see the previous email to show you how to load the solver package for this part. Now I'm going to click on the solver. As you see, these windows will be appear in front of you. So there are some other information that you have to consider. In the first step, it's asks you about the set the objective. What does it mean? That here it means that the value for objective function. The value of objective function is calculated here in the total, which is located in the D2. So I'm going to select D2 here. Then it asks you about the type of the objective function. The objective function that we have here is a maximization. So there are two or different options, minimization or maximization. Here we have maximization. Then we are going to go to the next part. It says by changing variable sense. It means that the value of decision variable. So you have to click here or click in the right side here and select the value for decision variable. Here we have 2 decision variables, so we are going to select these 2 cells together. So you have to left click and select all value for decision variable here. Then after that you have to go to the constraint part. It says subject to the constraint. We are going to add the constraint, so we have to click on add and these windows will be appear. Here is show the cell reference, sign and the constraint. Cell reference is shows the left hand side. The left hand side for the first constraint, as you see, is located in cell D3. So I'm going to select cell D3. The sign is a less than or equal, and the right hand side is the value here. You can write the direct value or you can select the cell here, which is F3. Then after you enter all information for one constraint, you can click on add and enter the other information for other constraint. I'm going to click add. I'm going to enter the information for the second constraint. The cell reference, left hand side, which is D4 here, sign, which is less than or equal, and the right hand side is 8. You can write enter 8 directly here, or you can select the cell. I prefer to select a cell here. And after you enter all these information related to the constraint, you have to press OK. And as you see here, we have 2 constraints as we have in this side. Then there are some information that we have here. Make unconstrained variable non-negative. This is a sign restriction. It's make sure that the decision variable are non-negative. So you have to put a tick for this part. And here we are going to use the solving method. There are different methods, but we are preferring here, because we have a linear program, we prefer the simplex LP. And after enter all of this information, you can click on solve, and you can see that the solver, as you see this the message came here, solver found a solution and all constraint and optimality condition are satisfied. So it means that we have a feasible solution, we find the optimal solution as well, and then we have to press OK. And as you see, this is the value for objective function that I've highlighted here, and these are the value for decision variables that we have here. So the value for x1 is 0, the value for x2 is 3, the objective function value is 12, and these are the left hand side for the constraint.